Please remember in this data pre-processing, some of the technique will be repeated for one or two aspects. So the four major tasks are: one is data cleaning, second is data integration, third is data reduction, and fourth is data transformation and data discretization. Okay. So in order to complete this unit, I require today's class and I require one more class. Okay, because we need to discuss a little about wavelet transforms and other things. So today I will just focus on some of the integration cleaning techniques and all. Apart from that, I will tell you one concept of entropy apart from all this, so that it is helpful for you in future in classification as well as in data reduction also. We speak about it quite a lot, but what it is like, I'll just explain. Okay. After that, we can go through the contents later on. So that is how we will. I'll move just back and forth because what I'm planning is I'll emphasize on some of the concepts like chi-square test, how it is to be done. Because some of the things are very simple. So very simple things I will walk very quickly so that you can just refer to. Because something is simply a formula and its transformation, I don't stress much. But I will stress much on the concepts where some logic is really involved and you need some focus on. Because I focused on the plots, the reason being there's a lot of practical importance for that. Because in industry, different clients ask for different kinds of plots for their business view and business analysis. So even the NASHCOM is very particular about some of the data visualization techniques required. Okay. So for that reason, I have emphasized more on the plots. Remaining some of the techniques like the data transformation, binning, smoothing, all these things are very simple and straightforward formula, which doesn't require much focus. So those things I'll go faster so that the syllabus coverage can be taken. So what are the aspects of data cleaning? Filling and missing values, smooth noisy data, identify or remove the outlier, and resolve the inconsistencies, if any inconsistency. So this is the part of your data cleaning. Data integration means I told you before also about the data integration that you will have data from multiple sources. So you need to come onto a common platform and all this about the data integration. Okay. Uh, so you have to integrate from multiple databases is one aspect. So your ETL process also helps there to some extent. And then data cube preparation are some of the facts. About data cube preparation, I just touched about the concept. If not, we went into the depth. Okay. By data cube building, you will have a higher level of abstraction and some of the summary values at some specific level so that you will have some better idea of things. Then data reduction. The data reduction consists of your dimensionality reduction, your numerosity reduction, and data compression. Okay. So these are the three different means. So for dimensionality reduction, you have the attribute relevance analysis and you will remove the irrelevant attributes, or you will see the correlation analysis and if any attributes are mutually correlating, they are strongly correlated, you remove those attributes. Like this, you will remove the attributes and that is nothing but the dimensionality reduction and the numerosity reduction and the data compression. Okay, then you reduce the number of tuples. Sometimes you go to the higher level of hierarchy, you generalize the tuples, or you go to the higher level of concept and replace the things with that, and the tuples can be reduced. Different techniques we will come across. And data transformation and data discretization. Again, data discretization also reduces the number of elements because you will discretize the continuous data. Suppose your income is there 2000, 2500, 3000, 4500, suppose monthly. You have different values. What you will do is in the discretization, you will say low income range. It is because the minimum salary is 4000, let us suppose. Nobody gets less than 4,000. So 4,000 to 15,000 or 20,000 is low income. 20,000 to 35,000 is medium income. 45,000 to 1 lakh is higher income. Like that, you want to segregate. So your income is actually a numerical variable and is a continuous variable. Now, because of discretization, that becomes a categorical variable, right? So it is discrete. Find this. So the concept hierarchy generation, how do you generate the concept hierarchy? We will see. It's a mind. And concept hierarchy generation is also not a tough topic. You can comfortably handle if I just give you the. But the entropy based, how you will find out the gain and all, that requires some knowledge. What is meant by that? Similarly, the chi-square test, are you aware of it before? Huh? Chi-square test. Have you studied in statistics? Huh? So you are aware of it? Huh? What is the practical importance of it? You have any? Otherwise, I have an example. I will work out the instrument fault or human error or computer error or transmission error. One of these things is a cause for that, and incomplete. Okay. Lack of certain attributes. Suppose you are typing in some attributes, the people will be the operator near a bit lazy. Suppose if somebody says, "What is your occupation?" They may say something. They will not listen. They leave it. Okay. Similarly, salary. Okay. The value is put as -10. You will never get a negative salary. So it could be the transmission error also. I told you. Suppose it is 10,000. Some of the bits were flipped. Suppose if the MSB is flipped, what happens? It's almost goes to half of the value, or even sign bit is flipped means go to the negatives. So you never know how it goes. So and inconsistent. Age is 42. Your birthday is something. Rating is 1, 2, 3. In at some other place the rating is ABC. So your 1 is to be mapped to A, 2 to B, and 3 to C. So intentional. January 1 as everyone's birthday. They made 1st January as everyone's birthday. But they just want to intentionally play around with the date. Because it seems some time back I have seen in the newspaper uh, somebody paid tuition fee for Amitabh Bachchan and some ministers and all those. He paid the tuition fee in a school, enrolled them and paid the tuition. So such kind of funny things will happen. Next. So how do you complement the missing data? Data is not always available. Many tuples have no recorded values for several attributes, such as customer income in sales data and all. So missing data can be due to equipment malfunctioning and all. Next, missing data may need to be in next slide. Again, a repetition there. One is you ignore the tuple. How do you handle the missing value? Is ignore the. If you ignore the tuple, When doing classification, if you ignore this, the class label is missing. What is happening is you get the appropriate proportionate data, right? Suppose you have 1000 tuples you want to use for classification. Based on those 1000 tuples, you are just analyzing the stuff, let us say. So you have the missing value. Okay. Suppose for 50 tuples, they are missing value. So you want to ignore those tuples. Let us suppose those 50 tuples are very, very important, crucial, top ranked tuples. Then it will have an impact on the decision. Then fill in the missing values manually. That means again you call the people, check the value. What is the value in this row you have sent? It is manually filling the value. It is tedious and expensive, right? Infeasible also sometimes. The data is from another place somewhere, or the persons are not there. It is the data of last month or something. It's infeasible also. Okay. So fill in automatically with a global constant unknown, isn't it? But still just saying that it is unknown doesn't carry any meaning. Then next thing is replace it by attribute mean. Replace it by the attribute mean. Suppose you have 10,000 records there. Find out the value of that average value of the attribute. Replace it by that. What happens with this? If you replace by the mean of the attribute, by the mean value of the attribute, if you replace, what happens? What happens if you replace by the mean? Please tell me. No, no. What you will do is you have 1000 records. Some 100 records are the value for the attribute for 100 records is. Then what he says is remaining 900 records are there. In the 900 records, you find out the attribute mean, average value of the attribute. Then replace that with that average value. That is what is meant. Remaining 100 values are being replaced by the average value of remaining 900 attributes. Getting my point? Suppose there is an attribute A. There are 900 values ranging from 20 to 95. Let us say. There are 900 values ranging from 20 to 90. Now the thing is, there are 100 more values missing. You got a data of 1000 records. Out of the 1000 records for an attribute A, 900 attribute values are present. And for 100 records, the attribute values are missing. Are you clear now? Now in such case, how do you replace the 100 values? Previously I said say unknown, or we said ignore the 100 tuples. Consider only 900 tuples for your classification. But it may impact the total decision analysis because you lost some tuples. You don't know what the value for those things is. So now the thing is, you are saying you consider all the 1000, but wherever these 100 values are missing, fill in every value with the average value of remaining 900 attributes. Got my point? Even with this also, there is every scope of having some false decision. Reason is, let us suppose those 100 the attributes with really very low value, or 50 of them are with very high value and 50 of them are with very low value, then if you replace the 100 by mean value, you are lucky. Got my point? But suppose in those 100, they are the very high value. If they are replaced by average value, that is going to impact your decision, right? Because previously I have shown you there are 10 things with 3 tuples with a marks of 87 are there, another with some 70 are there, 60 another 3, one is 50 let us. In that 3 values are missing. You just replace the 87, 387s by the average value which is something like 60, 65. Then your decision has totally changed, right? Because you will say 30% are A grade students you want to say. Instead you will say there are no A grade students at all. I have some 50% are average students. Some 3 people are above, 30% are above average. Some 20% are poor. That's the analysis you get. But it is really not. You have 30% extraordinary candidates. That is missing if you replace the top values by average values. You agree with me? So in such case, you are prone to get erroneous results if you replace it by average. So another thing what they suggest is, okay, let us not replace it by the average value, but let us replace it by a class average. What is meant by class average? That is, suppose income is there. Income we have segregated as low level, medium level, and high level income. So there are 3 categories. So what he says is categorize that. Now you have to take the average of low class, average class, high class averages and replace by the class respective class average. But you have to know to which class this belongs. That you have to analyze from the remaining attributes. Okay, that is one aspect. And another is the most popular value. That also becomes a tedious thing. But now another issue is fix up the most popular value. So the most popular value is inferred by regression or by Bayesian classification. Regression that is also one point. By linear regression or multiple linear regression, a multivariate linear regression, or by higher degree regression also, whatever is required. You will replace, you will find out that by that regression or you have Bayesian classification technique. Actually, in practice, people felt that the Bayesian classification really is giving a very accurate result. Bayesian classification is nothing but you will assume a normal distribution function for the data set which you are operating. So using that, you will be classifying the data. Okay, you will be classifying the data. So that is Bayesian thing. And decision tree induction is another method wherein you will make attribute relevance analysis on all the attributes and which is going to be the best split for this. We will see in classification how we will get best split and all this. Okay. The entropy there is a concept, but possibly today I will explain you about entropy. Apart from all this, then we will see how we will be using what is entropy, what is attribute gain and all. some minor introduction. Next thing is yes, incorrect. This is very common thing. Duplicate records, incomplete data. Yes, next. Now, how do you again for noise also the same reason for this. So I just push the slide. Same reason you will have for noise because of missing values or inconsistent data. Something same. And binning is one technique you will use to smooth smoothen the noisy data. Okay, noisy data means somewhere you get erroneous results, erroneous values. So here previously the thing is missing values. In missing values, you know that here the value is missing. But in noisy data, you have to find out which is erroneous value. Because if you get, I told you the actual value is 80. By just flipping of some bits of data, it has been recorded as 40. But both 40 and 80 are permissible range values only. So you cannot say that their 40 is wrong. So for that sake, generally from the plots I told you before, whether any gaps are there, we'll see. We are drawing some quantile plots and other stuff, right? Not quantile plot. You have the curves. You have the curves for correlation. We are drawing the data curves and all. At that point of time, also you will know when you are making. So uh, one thing is you have to smoothen the data by bin means, bin median, or bin boundaries, etc. There are certain methods to do this. Example is given. Next slide. Come back. I'll back to data smoothing is for that binning is one. How the binning is done. Initially, for doing the bin, it is not explained here. I'll explain. In binning, what people do is whatever data you have, it should be sorted. The data you this is how the data is. This is how your data is appearing. Now in binning technique, what you do is you just divide the data into some bins. Suppose you have equal size bins. Suppose you fixed the size of the bin as 3, let us say. Then you will have 4 comma 8 comma 15 in the first bin. Second bin is 21, 21. Bin 3 is 25, 28. 30. Now you may ask me a question. How do you decide the bin size? How do you divide this into different bins, right? Logically, what they do is from the observation or from the experience, they will notice that yes, if you consider these many tuples in one bin, they will because you are sorting them, right? So once you have sorted, okay, these many values will have the same neighborhood, like some kind of empirical estimate will be there. So depending on that empirical value, you will fix the number of records to be there in the bin. So here, of course, this is a simple example. You have 9 values, so we thought let's have 3 bins and we have put them. Okay. Suppose you have around million, you will decide how the things go ahead from the behavior of the data from some of the plants, something you will know, and then you will decide the bins. So here you have decided the bins. Now, what did he say for this binning? Take the mean value is one thing, take the median value, or take the boundary value. So if you consider mean value, mean of 4, 8, and 15 is uh, 4 plus 12 is 27, 9. Okay. So now, if you consider the mean value, the bin is 999. Here, if you consider the average value will be 22, so the bin will be 20. So replace all the elements with the average value. Other is 0.9. Otherwise, one more thing is replace by median. So if you replace by median, it becomes 888, 21, 21, 21, 28, 28, 20. Almost near to the mean, the median of. And another way of smoothing this is use the boundary value. That means the boundary value for this bin are 4 and 50. The boundary values here is 21 and 20, 25 and 30. These are the boundary values, the minimum value and maximum. Now what he says is replace every value with the nearest boundary value. Using data to discover rules and relationships to detect violators. Example, correlation, clustering to find outliers and all. So these things are there in data auditing tools. So in order to design these tools, it is a very complex scenario because you have to find out a lot of interdependencies and you have to analyze the things. So instead of you breaking your head, the tools will take care of that cleaning aspect. Okay. So now it has become because today there are many auto code generation tools are there. Even testing, you have different tests, right? Even the test script automation tools are there. The code will be generated automatically. You give data and say these are the rules and all. The code to test the test script will be generated, auto generated. That kind of tools are coming today. So you have data scrubbing and auditing tools. Then data migration and integration. Data migration tools allow transformation to be specified. Okay. In ERP and all, you have something called data mover actually. So when you are moving the data from one system to the other system, it will take care of all the triggers you have written. Let us suppose, uh, do you have the idea of data entry screens? Registration pages and web pages, right? For those things, you write some code, right? For validation of the data. Suppose you are using this data moving tools, and if you give some database table to that, it will consider what are all the validations that are defined in those web pages before. So those rules it will remember, and those rules it will use and test it out. So that kind of data moving tools are. So that itself will check all those things. And you can specify some more validations also while you are migrating, because it will understand the destination system setup also. So it automatically takes care of converting from the input side format to the output side format, so that it automatically takes care of that. Such kind of migration tools are. And extract, transform, and load. Another thing is ETL tool. This allows users to specify transformations through a graphical user interface. Simply you can say you transform this field, or you perform certain operations on the field and transform it. Whatever things are there. Your Informatica is one of the ETL tools. It's a very, very popular tool, Informatica. And Cognos is a visualization tool. These two things clubbed together, you use, they are very, very powerful tools in operation. And of course, in 2006, 7, I have seen. At that time, the demand was very high, but now still demand is there. But at 2006 and 7, it was so high. In Hyderabad TCS division, there was only one person dealing with ETL and Cognos together. So for their projects, he has got good demand. He was going to Gulf for one project. Immediately after 1 week, you initiate something and come back, and you have to go to Europe for some other purpose, and another 10 days later, you have to go to US. Like they're scheduling all his tours, because he's the only person was there in Hyderabad and dealing with the. At that point of time, I know that in US, people were paying $200 an hour. Even now, I was told it is 95 to $100 an hour for Informatica people in that, with some good experience. But in those days, it was in very high demand. Still, demand is there from data warehouse. Even today, $100 an hour is not a bad amount, right? $95 to $100 means $800 per day. There is income. Okay. So that is how the things will work out. We are only aiming at 40,000 per month. I'm asking you to aim at $800 per day. So these are the tools. So in fact, we have those tools in our department, but unfortunately, nobody is coming forward to use them. So they are just lying in cold storage. So integration of two processes. Because in 2006, knowing that we procured, World Bank has given funding for it. We procured Informatica and Commerce. We procured Windrunner and Silk testing software. So at that point of time, there was a good demand in Wipro for around 3 to 4,000 testers. So we negotiated with Wipro. They said if you train your people in Informatica and Cognos, sorry, if you can train them in Windrunner, even the average candidates can be absorbed. That's. But of course, it didn't materialize. We purchased the thing. For having lot of power problems at the part. Only 170 volt supply was there. So though we procured, we could not install and run the government. So ETL tool. So that is the importance of ETL tool. And integration of two process, iterative and interactive integration happens. It's called Potter's wheel. There is an example. Of course, I don't have much idea about the Potter's wheel tool and all, but about the migration tools, these tools I have ideas, so I'm able to explain you a little bit about them. because while I was working, I was dealing with some of the data moving tools and all during my work. So have some idea about it. Okay. Next is, next slide, please. Data pre-processing. So data pre-processing is as data quality, as data integration. Last slide, minute. Next slide, please. Next slide. These things I think you can follow a bit easily because I want to tell you some of the aspects about redundant data occurs with integration. This aspect I will discuss a little later. Okay. Next slide. Already three, and I have to just cover some of the statistical tests for this. So I'm coming to the correlation analysis. For those silent, because that's not very tough. That is only giving some information to you. So instead, because I need at least some half an hour time to discuss this test. Because otherwise, what happens if some 10 minutes or 15 minutes is left, we can't discuss this with a comfortable. So that's why I'm just putting that part. What is this chi-square test? Before this chi-square test, you should know what is correlation. You know pretty well about, you have done correlation, right? The correlation coefficient and all. You are perfectly negatively correlated, you will get -1. And in between values, it is the thing. It is 0.9, it is more correlating. Hello? Oh, ఇప్పటిదాకా మైక్ ఆఫ్లో ఉందా? So, my dear students, this is the formula for the correlation coefficient between A and B. So, you have two attributes A and B. So, A has some n values, A1, A2, etc. An. B has again another n values, set of n values, B1, B2, etc. Bn. Now, our intention is to find out whether A and B are correlating, are they connected to each other, or they are independent of each other, or are they correlated in a negative fashion. How they are being correlated is the criteria for us now to find out. So here, for that the formula is sigma I running from 1 to n, ai into bi minus n into a bar b bar by n into sigma a sigma b. If this is 1, attributes a and b are perfectly correlated. This -1, they are perfectly negatively correlated. If it is 0, there is no correlation at all. If it is in between, there is a kind of proportion. Of course, in my yesterday class also I have shown you, if you take any two sets of numerical data, for two sets, some correlation might occur incidentally from the values, but that logically doesn't make any sense. In my yesterday's class, I have shown you an example. That is in the New York strawberry jam selling versus Florida music CD selling. There was a very good correlation between those two. But incidentally, the data values are so formulated such that. But logically speaking, there is no correlation. So you have to be careful about it. First of all, you have to decide for which two variables you have to check correlation. Whether is it worthwhile checking the correlation for those two attributes, you have to initially choose. And once you choose that, then you will apply the formula and you get the correlation coefficient. That is fine with the numerical value. Okay. Suppose now you have some distinct values or if you have a discrete data, there is one more test called the chi-square test to find out this kind of, find out a kind of hypothesis is valid or suppose you make some hypothesis and you will know whether the hypothesis is valid or not. That is the thing you will be going ahead. So here we have an example to find out. And suppose you have two variables A and B. Here we have the correlation example is that you can just move to this, keep going. The chi-square test, the significance is it is sigma of the observed value minus expected value whole square by expected value. That is called the chi-square. So that means what happens is you are having some expectation depending on the number of elements. Some expected, how you will calculate expected value, I'll tell you. And you have the actual observed value. So if the observed value minus expected value whole square by expected value to calculate a figure, this is considered to be the chi-square value. And if the chi-square value is more, then there is a correlation between those two attributes. That is the meaning of your chi-square test. Okay. If there is no, if the value is 0 or very less, there is no correlation. That is the meaning of it. Okay. And I'll be working out a problem also. It is there also. So if you consider two variables A and B, okay, and let us suppose A takes some distinct values, A takes some distinct values ranging from A1, A2, etc. A and B takes some distinct values B1, B2, etc. BR. Okay, you will have, see what is meant by the distinct values and the actual values. Suppose you have a data set wherein you have two attributes A and B. A and B both have around 1,000 rows. So that means for A, you have A1, A2, A3, etc. AN, A1000. For B, you have B1, B2, B3, etc. B1000. But if you consider, there is every chance of getting the values repeated. Do you agree with me? But here, the distinct values means out of the 1,000 values for A in the given data set, how many distinct values are there? The values might be 1,000, but the actual distinct numbers, if you consider, that could be 100 only. So you have to consider those distinct values A1, A2, etc. A, C are the distinct values for A. Similarly for B, you have B1, B2, etc. BR, because there is no compulsion that A and B should have same distinct values or same number of distinct values. A may have 50 distinct values, C may have 70 distinct. It's different. But A1, A2, etc., you will have 1000 values. For B also you will have B1, B2, etc., 1000 values. But if you look at now, if you consider this 1000 by 1000 matrix for A and B, so each cell will contain one pair of AI and BJ, which are drawn from the distinct sets of A and B. Do you agree for that? My dear students, do you agree with my logic? Have you understood that? No one is responding. Have you understood that? I hope you are all clear with this, right? Now, in fact, your chi-square is mentioned as sigma I is equal to 1 to 3 sigma is equal to r of theta ij minus ej whole square by 3. This is the formula for your chi-square value. Here, your Oj is the observed value, Eij is the expected value. So, how do you get the Eij? So, your Eij is your count of A is equal to Ai multiplied by count of B equal to Bj over where n is the total number of data tuples you are considering. No, no, your observed thing, total count. You will know from the example. Okay. So now your count A is equal to A is the number of tuples having value A for A, and count B is equal to BA is the number of tuples having BJ for B. Now, because you will make some proposals and for that you will take the counts. That's why I told you with example you will understand. Anyway, I'll make A is equal to AI number of is the number of tuples having BJ. generally goes with a kind of proposal. Okay. Now I'll show you the example. Here they made a statistical observation with reference to fiction and non-fiction novels reading. Okay. This has been this observation has been made between male and female persons. Okay. Now, if you look at, so from this you will understand. Here you what you will understand. There is a study. So that is says that fiction, non-fiction novel. So 250 males liked the fiction novel and 200 females liked the fiction. They made a study. And as far as non-fiction is concerned, only 50 males studied the non-fiction, whereas 1,000 females liked the non-fiction. Okay. So there was a survey in which some persons participated. In that, 250 male people said we like fiction now, and around 200 females said yes we like fiction. In the same survey, when they asked about the non-fiction novel, only 50 males said we like the non-fiction, and whereas 1,000 females said we like only non-fiction. So the ladies do not like the fiction novels. Only 200 ladies liked the fiction novels, and non-fiction novels were read by 1,000. Probably they want to be more realistic. They didn't like the non-fiction, as they liked only non-fiction. So that is how the study. Okay. So now, how do you go about this correlation? Okay. What is the chi-square? Now, what are all the possible pair of values here for you? What are all the possible combinations? Because A has distinct values, I said A1, etc., A2. Right? Here, what are the two distinct values for gender, male and female? For novel type, fiction and non-fiction. Both are 2 by 2 only, right? So when you have both are 2 by 2, so the possible things are Eij. So E11, 12, 21, 22, right? So E fiction comma male is one thing. So E fiction comma male is how much? Uh, See, you have the expected values. What is the expected value? What is the formula for expected value? Your Eij is equal to count A is equal to Ai into count B equal to Bi over N. Right? That is the formula. Got my point? So here, what is N? The total. N is the total number of tuples. Please remember. So what is the total number here? How come you got that? For fiction, 250 plus 200, 450 participated. For non-fiction, 1050 participated. So this is 450 and this is 1050. Total is 1500. So your N is equal to 1500. Now your fiction male. So what is this value? It is count A into count B by N. Ah, no, no, no. The thing is not fictional participation. What is the total population participated in? You will find out the proportionate share. Yes, that's what. Because he has come to the survey. Okay, there are 1500 set of people. So he asked some of them. Then what about your idea about fiction? But you said, yes, I like fiction novel and now. Non-fiction guరించి you didn't mention anything. Let us suppose. So it is observed that, see, about fiction, if you consider there are only 450 participated, and the remaining people said, I have no idea, or I don't bother about it. Right. But 250 said, male said, we like fiction novels. And 200 females said, we like fiction novels. Remaining people might have said, we don't like, but don't like part we are not covered. Our proposition is there any correlation between the gender and liking to the novels? That is our proposition. Okay. Whether it is false or true, you have to find out. If it is strongly correlated, you say that yes, there is a correlation. If there is, if the value is chi-square value is very less, we say that there is no correlation. Got the point now? So now your E of Fi comma M is equal to how many males are there total? 300. So your count is 300 into 450 is the total participation in fiction. That over 1500. So the expected value is there are total 300 males, but out of 1500, how many said fiction we like? Only 450 participated for fiction out of 1500. So 450 by 1500 into this 300. That is the proportion of, that is the expected value. Okay, are you convinced here? For EA value, expected is the number of people, the number of males are 300 in this. The total number of fiction now participated are 450 total number. So 450 by 1500. 300 into 450 by 1500. So 90 is the expected value for the fiction novel, which people used to say. But what is the actual figure you got for fiction among the males? 250 is the one. So the difference is 250 over 90. Right? That's very well. Similarly, if you consider for deeper fiction among females, it is again for fiction the total population is 450 and the females participated is 1200. Just try to understand a little here. Okay. Please remember, total 1500 students were, sorry, not students, I'm sorry, habituated with the word student. 1500 persons were interviewed in total. Okay. But here, when there is an expression about the fiction novel, 250 male members said, we like fiction. And 200 ladies said, we like fiction. As far as non-fiction is concerned, only 50 male members said we like non-fiction. But 1000 female members said we like the non-fiction. That is how the interview results are. Okay. And they ask, these are this. So generally, overall, only 300 male members participated in the survey and around 1200 female members participated in the survey. So ladies are more active in this survey. So now here is you want to find out the difference between the expected values and actual value. Okay. So here the expected value is considered as, if you consider all combination, for each combination, what is the total count independent? So what are the possible combinations? Fiction by male, fiction by female, non-fiction by male, and non-fiction by female. These are the four combinations, right? Do you agree? These are the only four combinations possible. If more number are there, you will have more number of combinations. So four combinations are possible. Now, here, if you consider uh, among the male, how many participated in the fiction? 250 plus 50, 300 parts. The total males. The total males participated are 300. Okay. Now, how many participated for fiction? 450 members participated for fiction. Rather, 450 members voted for fiction, let us say. So 450 members voted for fiction means what is the proportion? How many are there in total? 1500 are there. So out of 1500 population participated in survey, forget about male or female. 450 members voted for fiction. Okay. So 450 by 1500 is the proportion that has voted in favor of fiction. Do you agree? Now that is the case. How many males could have been voted in favor of the fiction? 300 into 450 by 1500. So 90 should be the expected value. Do you agree how you calculate the expected value? Because the probability for liking the fiction is total 450 participated out of 1500. So 450 by 1500 is the proportion. There are 300 males total in survey. According to this proportion, 90 need to say we like fiction. But how many said we like fiction? 250 said we like fiction. So there is a big variation. So that's why it is 250 minus 90 square over 90. Because what is the chi-square test is? The formula is your OI minus EJ by EJ, right? So your EJ is 90, your expected value. Okay. So with reference to the expected value, we are finding out the proportions. Now, if you consider the female, how many female in fiction? For the fiction proportion is 450, but whereas how many female are there? There are 1200 female. So this proportion is 1200 into this 450 by. This would have been the number, but the actual number is only 200 females said we like fiction. So that's the difference, right? So same way, if you calculate, there are 1050. Similarly, non-fiction and male, 1050 into 300 by 1500. So similar proportions. Non-fiction female is 1050 by into so and so 1200 by this. Oh, I have put the same value here. I'm sorry. This is 360 for this. Non-fiction male is right. It is 210. Sorry. That's 1050 and this is 840. So now it is 50 minus 210 by 210. 360 so and so 1000 minus 840 by 840. So the value has come down as 507.93. So higher the value of chi-square, the stronger the correlation is. But how do you know that this value is on higher side or lower side? Normally in statistics, this is on higher side. Normally in statistics, especially for chi-square distribution, the statistics books have given some tables for it. They have something like the degrees of freedom. So degrees of freedom is n minus 1 by n minus 1. So here 1, 1. So is 1 degree of freedom. So for 1 degree of freedom, if you consider the chi-square value from the tables, they say it is something like 9 point something, I don't remember. is something like 9 point some value is there for that. Now you please go ahead and whether he worked out or something. Okay. I think he has not given the. Uh, but you got 507.9. So what they say is if you get the less value, you say that they are not correlated and there is no, the proposition is correct. Like that is, there is no dependency. But here, the 9 is supposed to be an independent value for that 1 degree of freedom. But the value you got is 507. So your hypothesis is false. That means you have a good correlation that implies. Okay. So there is a correlation between the gender and liking the novels. Okay. That is the proportion here for the given set of objects. Again, this is applicable to the given set of observations only. This might have happened in a village. But whereas if you take the opinion in JNTU, okay, probably ladies say like fiction novels. Or who will see that? Old novels and all, right? They are the advanced people and say we all want fiction. And the results might differ. So this is the chi-square test for finding out the correlation of some kind of hypothesis to the test. Okay. Set play chess, not play chess. This is about the chess playing has given same. In the textbook, what I have, the example I have told you is from the textbook. But in the PPT is just changed who play chess and do not play chess. Correlation analysis, yes, we have gone through this already. They are the standard deviations. The values for correlation are shown there. So I think it is, and now I can stop here. So I require one more class. Basically in that class, I will emphasize on wavelet transformation, then principal component analysis, then on discretization and the concept of entropy. These four concepts I will emphasize because they are the things which you need to know. And rest of the things you have that score normalization. All very simple, but I think probably I can cover the data transformation concept brief because in the data transformation we have the smoothing is there, aggregation is there, generalization is there. About aggregation, generalization, we can speak in the next class. Normalization is one thing. So the normalization means what for we will do normalization is suppose you have two attributes. Income is one attribute. Its range is from something like 4,000 to 1,50,000. The range is high. Suppose some other attribute is there. It is age. So it may range between 21 to normally till 21 nobody will get employed. Is from 21 to something like 60 at the 60 people. So 21 to 60. So this is ranging from 21 to 60. The other one is ranging from 2,000 to or 4,000 to 1,50,000. So there the range is more. So in such case, we go for something called normalization. We map the values into a smaller scale value between -1 to 1 or 0 to 1. We'll map them accordingly using some kind of techniques so that visualization will be more comfortable for us. Okay. So we will discuss that feature and the remaining things in the next class. So I will emphasize on the difficult parts which you need to be covered. Rest of the things I will just touch. And by next class, we will be finishing our topic on the data prepare. Okay. So any queries from people, you can come for the interaction. The colleges, from your side also. If you have any queries, please feel free to ask. Any queries from your side? Right. Okay. We have a correlation saying that the liking of novels is proportional. So there is a correlation between the gender and liking of the taste of. Mm. No, that's what actually what we concluded based on the gender you can say. That means you can say uh, ladies prefer non-fiction novels, men's prefer fiction novels. Like you can come from this data. Okay. That means the gender and liking of the novels are correlated. Of course, for your example, I have shown you only some four variables. But in reality, if you look at, you will have something like 100 variables and another set some 50 variables. So just by mere observing the data, can you do that? This is an example to make you understand. If I start with the real-time data with some 100 distinct values for A and 50 distinct values for B, even the calculation itself is a tedious one. And you can't really understand. This is to make you understand. I have given you a simple example. Yes, from the observations. So you are saying that your observation is correct from the formula. Okay. No, no. I am just saying there is a correlation only. That's what. There is a correlation between gender and all. Rest of the things from these probabilities you have to observe. Okay. But we will say that there is a correlation. The hypothesis is male like this and female like this. That's not the hypothesis. The hypothesis is say there is no connection between gender and this is the hypothesis. But we say that we negate it. No, there is a correlation between the gender and the novel read. That's it. Okay. Ah, yes, yes, you can select one.